Greetings, you are watching TFI, where we're going back to basics here, mate. We're going back to beginner level stuff for the newcomers to Autodesk Inventor. So if you've stumbled across any of the other videos on my channel, you might have noticed that they are, admittedly, sort of medium to high range content. Very point focused subjects. Assumes most people have got a knowledge of Inventor already. So let's not forget about the beginners. There's always new people coming through that need a few tips and tricks. And these are the 5 things that I remember when I was getting started on Autodesk Inventor that I couldn't work out myself. That absolutely boggled my mind. Now, don't be disheartened though. You'll not be an expert after watching these 5 tips. Inventor is a hugely complex subject, and there could have been 50 tips in this kind of a video, and I've just narrowed it down to 5. So don't be disheartened if after this you're still struggling a little bit, and after a few other tutorials you're still struggling a little bit. Don't be disheartened. That's a good thing. I'll tell you why, mate, because in life there's 2 things that are certain. The first thing, with physical objects, if they're heavy, then they're expensive, and with software, if it's too easy and simple to master, then it's not worth mastering, and that's the case with Autodesk Inventor. It's complicated, complex, and in-depth for a damn good reason, mate, and it's worth mastering it, and it's worth sticking in the time for it. So here we go with my 5 tips that absolute beginners for Autodesk Inventor should probably need to know about. Right, mate, let's get cracking, and the first tip is parts and assemblies. I vividly remember this blowing my mind when I was first getting started with Inventor, because maybe like you, prior to using Inventor, I had no experience with any 3D CAD. I was used to AutoCAD and 2D, lines, arcs and circles, so the concept of using assemblies and parts and separate pieces kind of blew my mind a little bit. So the way I now explain this to people, and it seems to go down quite well, is if you look around the room you're in right now, right in front of you, you might have a phone, you might have a keyboard, a monitor, a mouse. These are items that are made up of multiple pieces. If you were to completely disassemble, say for example, your keyboard, and break it down to its component parts, and then throw them all onto a desk, all of these parts here would be IPTs. They'd be modelled separately as IPTs. The keyboard membrane here, that would be a single IPT. If that could be disassembled further, they'd be IPTs, but it's not, it's just one in itself. And then what you do is you go over to Inventor, and then you start an assembly, which is empty. And you don't model anything in here. What you do is you just say, I want to place an IPT into the assembly, and you take all of the parts that you've modelled separately, and you put them into the assembly. And then you constrain them together. You push face to face, and put a pin through a hole, and they're called constraints. But yeah, in essence, the assembly is made up of a collection of parts, and what you can then also have, mate, is you can have assemblies in assemblies. Say for example this bearing here, right? If you were to buy this bearing in, the bearing is made up of 3 parts. You've got the inner ball, you've got sort of the bearing bit here, and then the outer casing. Those 3 parts that make up the bearing are a bearing assembly, and then you place that bearing assembly into the overall bigger item that you're designing. So that's called a sub-assembly. So there you go. That's how I kind of think of it now and explain it to people. Disassemble something, throw everything onto the desk, those are the parts, put them all together, and you've got yourself an assembly, mate. And tip number 2 for the absolute day 1 beginner is utilizing the end of part icon in the part browser to try and understand how something was put together. So this won't help you understand how each of the buttons work as such, but it just helps you get your head around what someone was thinking when they made a model. I remember vividly looking at this model. It was about 13 or 14 years ago. I'd never modeled a single thing in Inventor, and this very wheel that you're looking at right here, I remember opening it up because it's one of the Inventor sample files from about 13 or 14 years ago, and thinking, how do you even begin with that? I mean, where do you even start with this? But what you can do is you go down to this end of part icon here, drag it all the way up to the top until the horizontal bar vanishes. So you just get it so the first bar appears, and you've essentially stepped back in time. And what you do is you just grab it again and pull it down until you start seeing things appear. And then you can examine the sketches and the 3D features that made up that part. So that's the first thing someone did to model up this wheel. And then they modeled the first spoke, and then they span it around. And you can just keep left click, drag, let go. Keep left clicking, drag, let go, and it slowly builds up the model. So you're almost looking into the mind of the person who did the model, understanding what they were thinking as they went through it, how they started chiseling away at the object. And before you know it, mate, you're knocking out stuff like this. This is a wheel that I did about a year ago. And then doing the exact same thing, I can drag the end of part all the way up to the top, because even I'll forget how I did this. I'm looking at it now thinking, did I did that? Okay. And then, so I started off with this sort of plate thing here, and I rotated a spoke around there. It's all based off roughly real dimensions. And then did the first little wedge here, which forms the start of the spokes, and then sketched those out, and then that, and then spun those around, and then eventually you get where you want to be. But yeah, you can just start stepping through the part to see how something was built. It just helps you understand the techniques and the order of certain features and what the best way of creating something is if you're just struggling to get your mindset right before you start creating a model. That's the end of part icon in the model browser. Right then, tip number 3, mate, is iProperties and bill of materials. Now, on day one, when you're just getting used to Inventor and you're learning it at home and you're just playing around with it, you don't need iProperties, you don't need bills of materials. But if you're using Inventor or learning it with the intention of using it in a job later on, then yes, it's probably a good idea just to know that they're there. Don't need to do much with them, just know that they're there and what they do. So iProperties, let's start with that. If we go into a new part, but by the way, every single part, assembly and drawing in Inventor will have a set of iProperties. We'll go into a new part, go to the file menu here, and then iProperties, or you can right click on the node and go to iProperties. Inventor then gives you a dialog box with a bunch of tabs along the top. Each one of these tabs contains iProperties. Every one of these text fields is otherwise known as an iProperty. It's a property unique to Inventor. And you can make of these what you will, mate. You don't have to use all of them. Most companies don't use these text fields, but you can make of them what you will. Like, for example, on the project tab, there's a few in here that are really important. Things like part number, because that gets called up into a drawings parts list later on. So you can type your part number into there, your description. You can say 4mm steel bracket, for example, or whatever the description is. The revision A. The rest of them can be left blank. Some companies won't use all of these. Some companies will use them all, but they'll have their own interpretation of them. Things like cost center and authority. What the hell does authority mean? I don't know, but it can mean whatever the company wants it to mean. So you can fill all them in. You can go to the physical tab. You can put in your material here. You can see this is made of stainless steel, for example. And then it'll calculate mass, area, volume, center of gravity based off of the modeling that you've done and the material that you've picked. And you can also create your own properties. So if your company has its own unique properties, you can type them in here. You might have a unique code for your company, which is in addition to the part number. And you can add that in, and then someone can come in here and type in whatever the unique code is, and then that's now unique to that part. So those are the iProperties. Definitely worth just knowing that they're there, because they are used in the bill of materials. So if we head on over to an Assemblies, there's an IAM file, go to the Assemble tab, click bill of materials, and the structure tab. You can see here we've got a number of columns. This is the bill of materials. It's a list of parts that are required to assemble and make this assembly. So it's automatically itemized all of the parts, and then it's called through the part number from the iProperty. So this part here, you can see here that item number 1, part number is M-SP-1073, and there's its description there. Each part also has a BOM structure. A BOM structure is a little tag, a label assigned to every single file in Autodesk Inventor that dictates to Inventor how that part behaves in a bill of materials. But by default, everything's normal, but you might have something that you don't want to be in the bill of materials. Like, say, for example, if you're a company that makes pedal sets, right? You make the pedals, but you make them around a third-party supplier chassis, for example. So we might make these pedal feet here, but we don't make these here. So when we're assembling this all together, we might put in supplier parts, but we don't want them to be in our bill of materials. So you can select those supplier parts and then make them reference. Double click in the cell and then make them reference. That tells Inventor, these parts here, don't use them and put them into a parts list. Don't add their weight into the weight of my assembly, because they don't really exist when it comes to us buying in these pedals or making these pedals. So that's how you can set things as reference. Construction geometry, big blocks that you reference dimensions off, those can all be reference parts as well. So yeah, just understand that the bill of materials is there. That's where everything gets itemized. Your parts list and your drawings ultimately calculated off the bill of materials. And yeah, that's your iProperties and bill of materials, mate. Just be aware. You don't need them on day one, but just be aware that they're there. And on to your 4th tip. This is all to do with saving files in an organized project. It's file management, mate. This is all to do with where you save your files. And the reason this is important is that when it comes to a 3D CAD application, there are loads of files, mate. You've got the assembly, you've got all the parts that make up the assembly, you've got your drawings, and it's impossible, absolutely impossible for Inventor to keep track of a part if you move it somewhere else on your hard drive. Like, say, for example, this blower unit here. If I was to take this frame, right, and cut that and then move that to the desktop, right? Let's just drop this onto my desktop and just see what happens. So I'm going to shut down the blower, reopen it back up, and what you're going to see is Inventor goes, right, I can't find this frame piece. It went completely missing. What do you expect me to do? Search your entire hard drive and your network, all the servers in your company to find this one frame that you've moved? No, that's ridiculous. It can't do that. It's impossible. So just one move of a file can just completely just disintegrate your assemblies and just annihilate them. So what's highly recommended is that you create a project and then save all your files into an organized folder structure. And it's pretty easy to do. You just go into projects, select new, and then say I'm going to create a new single user project. Let's call this my TFI project, but it could be whatever you want it to be. And then the project workspace folder is like the top level folder where all of your files are going to be saved underneath. So I would click these little three dots here and then save them somewhere that you know, like an external hard disk or your like a data drive on your computer, something like that. So for me, I'm just going to go with my C drive underneath an Autodesk folder. I'm going to create a new folder called my TFI project, and then click OK in there. And then that's going to put what's called an IPJ file into that TFI project folder. So let's just jump over to my C drive and we'll just see what it's made there. So we're going to C, Autodesk, my TFI project, and it's created this IPJ. IPJ is an Inventor project file. When you load up that project file, that instructs Inventor to always look inside this folder for any files for anything that you're working on regarding this project. So underneath here, you can create a new bunch of folders. You can say, right, we're going to create assemblies. That any assemblies can be saved into that folder. Parts, drop all parts into that folder, and then drawings, for example, you can put all the drawings in that folder. But you can create whatever folders you want, call them whatever you want. You can have as many folders as you want, as long as they're all underneath that TFI project folder. Inventor's always going to search. If anything ever goes missing, if you move anything around between the folders in here, Inventor will always search all of these folders for any files that you might have moved around. And tip number 5 out of 5 is sketching, mate, because this one catches a lot of people out. Most people that start on Autodesk Inventor for the very first time have normally come from a 2D background, so it's kind of natural to try and sketch, which is unavoidable in Inventor and any other 3D program. They try and sketch the way they did in the 2D program, hoping that it kind of works out for them, but it just doesn't. So let's start with the new IPT. Let's jump into a 2D sketch and drop that onto the XY plane. So this kind of looks like AutoCAD. You've got this sort of top-down view and you're given lines, arcs and circles. And what people try and do, mate, is they try and draw a line and then they'll press escape and then they'll draw another line down here. You know, we're trying to draw a right angle here, and then they'll go to extend and they'll try and extend it down, and then they'll sort of trim that back to there, when all they needed to do was draw a line, and then they're now joined. It automatically joins things together as you're sketching. So there's a couple of habits to try and get out of, but the way Inventor works with sketching is that it relies on things called constraints. AutoCAD now has them. Back in the olden days it didn't. It was easier to teach this before AutoCAD had its constraints and its parametrics, but Inventor relies on constraints. So say, for example, you want to draw let's keep it really simple, a plate 100 by 100. You can draw yourself a rectangle, click the top corner, and you can type in 100, just like AutoCAD, tab 100, and then press return, and that draws you a plate 100 by 100, and you get loads of glyphs thrown around, mate. These glyphs here show you how the lines are constrained. So with a rectangle, Inventor automatically makes these lines parallel with each other, because it's a rectangle. Of course they are. These lines are always going to be in line with each other, as are the top and bottom lines. But because it's green, that means that this rectangle, or a square in this case, is free to move around the sketch. So you can grab it and then it'll sort of move and float around. That's non bueno. You want to try and avoid that as much as possible. So you use these constraints up at the top to sort of fix the geometry into place where you want it to be. So you'd say, right, I want to make a horizontal constraint and I want to line up the middle of the square to the center of the part, and then I want to line up that bit there to that bit there. And the same goes for any extra bits that you sketch. You can rely on endpoints, but you don't have to. You can just draw a line wherever you want it to be, say 60mm, for example, and then you can create this thing here, which is a coincident constraint, and you can just say snap that onto there, and it'll just snap it there, mate. It's easy as that. So you don't have to be exact right from the bat. You can sort of freestyle sketch something that you roughly know what you want it to look like, and then once you've done that, you can then start using constraints to fix it up. Make that line horizontal, make that line vertical. Press D for for a dimension, and you can put in a dimension between these two lines here and then make that angle 90 degrees. You can do whatever you want after you've sketched it. So try and get away from the AutoCAD mindset of using trim, extend and scale. You don't need to do that. You can just use constraints, and then you can use dimensions to make things at their final size and their final shape and position. And then those dimensions, those constraints control the size of the objects on screen, with the end goal being all the lines blue rather than green. So that's your sketching tip as tip number 5, mate. Reese, I've got a few honourable mentions because I just couldn't leave it at 5, mate. There's too much here. I think an absolute beginner needs to know about, but I didn't want to make it a 10 tips thing. And the first one is, mate, don't try and do too much too quickly. Don't expect too much of yourself too quickly. Even if you go on a 4-day intensive ATC official Autodesk training course on Inventor, you'll not leave it being an absolute legend on Inventor. Nobody's going to expect that much of you that quickly. I refer back to my first point, that it's a complicated package for a reason. It's difficult to master. So me, for example, on my very first day of using Inventor, I kind of got my head around the buttons and looked at how things were structured, and then over the next few months I modelled the laptop that I was using Inventor on. That's how I learned Autodesk Inventor. I literally modelled the thing I was actually using at the time, and that taught me so much about the program. We've got decals here, putting stickers onto parts. How do you, I still can't work this out, how do you put a unique letter on each key? I haven't tackled that yet. But just like fillets and chamfers and different, variable radius fillets, and really useful experience to go through and model up something that was quite exciting to do, quite interesting, quite challenging, and it was right there in front of me, so I can take out a tape measure and actually get some decent sizes off it. So yeah, don't expect too much from yourself too quickly. Take it slowly, be patient. It's worth mastering it, but don't expect too much too soon. And honourable mention number 2 is, mate, don't worry about the application options or any settings or anything like that. I see this quite a bit in the comments. It's like, what settings have you got? What application options should I have set up? It doesn't matter, mate. You can just install Inventor right off the box or from the torrents, wherever you get it from. And you can just leave the application options well alone. Inventor does have a bunch of options here with a load of tabs and a load of things you can tick and configure. You don't need any of these. When you eventually get into a job, there'll be a CAD manager who'll set these up for you. But on day one, you don't need to change any of these to assist you modeling up something that you need to model up. Just leave that until later on. What will tend to happen is you'll think, this thing's really irritating me. I'm sick of this little dotted line that's appearing out when I'm trying to do a sketch. How do I stop this dotted line from appearing? And then you'll dive into the options. You'll look for the one that sort of roughly sounds like what you might think it does, and you'll just learn the options over time. But don't worry about these at all. You can stay well clear of them on day one. And honourable mention number 3 is all to do with hardware, mate. Don't worry about the computer that you're using on day one when you're just getting cracking. If you've got an absolute horror show of a computer or a laptop, it's 14 years old, it's an old Dell laptop, it's got 4 gigs of RAM, it's still running Vista. As long as Inventor can install, and Inventor will install on most operating systems, as long as it installs and opens, you'll be able to learn the program. You'll be able to jump into an IPT. You'll be able to play around with sketches and draw lines and arcs and circles. It'll work. You'll just not be able to get onto bigger assemblies, which, to be honest, mate, you're probably not going to be doing for quite some time if you're on day one. So for just learning the program, a horror show of a computer or a laptop will not stop you from using any of the buttons. It might be a little bit, there might be a bit of a lag here and there, but it's fine. It's not going to hold you back in the learning process. But in a drawing office environment, for example, yes, we do go for much higher end computers for handling assemblies that have got hundreds or thousands of parts in them, like this car, for example. You need a pretty beastly computer to be able to spin this around smoothly. But on day one, don't worry about it too much. As long as Inventor will install and open on it, you'll be fine. And our final honourable mention goes to something which I briefly mentioned earlier on, which is, mate, just find something that in the room that you're mildly interested in. You think, oh, that looks cool, that'd be nice to model that, and just have a go at it. Just play around with it and click buttons. Honestly, go into a part file and just click buttons and see what they do. If you can't do something with a button, Inventor will feed back to you why it can't do it. So extrude, it's saying here, oh, you need a 2D sketch to create an extruded feature. All right, and then it'll sort of guide you through it. Same goes for revolve. You need a 2D sketch to create a revolved feature. It'll tell you what you need to do. Some of the tools won't give such good feedback, like for example Loft just gives you this dodgy dialog box, but everything is just an undo step away from being fixed. If you mess something up, if you open up somebody else's part and then you tweak a sketch and you pull something and it sort of disjoints itself, you can just undo it. It's always there. Alternatively, you can just click save the thing. If you know, right, this is a safe position, this is where I haven't done anything to it, save it, and then just shut the file down and reopen it if you completely mess it up. Inventor doesn't have an autosave, so you'll always have that save to go back to. So yeah, just find something that you're mildly interested in, play around with it, click buttons, see what they do. You've always got undo, or you've got save to jump back to as well. Alright then, Chief, there you go. There's your 5 essential tips for Autodesk Inventor Day 1 beginners. Hope you found that useful, and if you sat there thinking to yourself, mate, this bloke, he kind of talks fast, but I'd like to see more stuff from him, well then get subscribed, and if you go on over to the channel and then select the videos tab, you'll see I've got hundreds of videos on Inventor dating back like 5 years, mate. I've in fact started a series where I'm covering every button in Inventor. Wish I didn't start that now, but I've got to finish it. So we're getting through that. There's tutorials here ranging from beginners through all the way to advanced. We've got Vault, we've got Fusion 360, there's rendering, there's VR stuff here, there's PC benchmark stuff for Autodesk Inventor. The alloy wheel rim tutorial, if you do a search in here for BMW M4, for example, you'll see the tutorial appear. I've got one for Fusion 360 as well as Inventor, as well as a tyre. Forgot I'd done that one. So yeah, get subscribed. Get liked if you want to see more from the channel, and I've had a few people asking about donating to the channel because Patreon doesn't appeal to them. Well, links are in the description if you want to do that. No obligations, obviously, but I have been asked. But anyway, thank you very much. I hope you found it useful. Good luck on your journey. To anyone that just watches this just because for the hell of it, then thanks, I guess. Thank you for sticking through it, and I'll see you in the next one. Toodles.